In this tutorial, we're going to look at a way to make a glass of liquid that when tilted, the liquid inside will stay level with the ground. So if you wanted to show somebody starting to drink a glass of liquid, delicious glass of liquid, you can do this. There's nothing fancy, just using a boolean. But the reason I started doing this was because I was looking at ways to make a toon shader transparent. So the two subjects here, adding transparency to a toon shader, and then also making this sort of fake liquid on the inside that will stay level even if the glass rotates. Okay, so let's just set this back. Now, I don't think we really need to go into making something like this. All I did to create the glass was to make a cylinder, select the top faces, and then scale, hold down shift, extrude it in, translate, hold down shift, extrude it down, right? So then you've got a glass, and then if you wanted to, you could go in and bevel out these edges using the bevel tool, changing the fraction and the number of segments that you would see in there. And you could do that on the inside edge here too. Right, so you can just easily make a glass, and I guess you'd also want to bevel these edges here. So reduce the fraction, increase the number of segments, and there you go. And I guess if you wanted to, you could smooth it now and it would hold its shape, and so on. So, and if you wanted to make the inside surface, you could duplicate this glass, delete all the faces except for the inner ones, and just extrude the edges of the top inwards using scale to make the top surface. Anyway, doesn't matter. You can do this however you want. But if I just take this glass and duplicate it, delete these children, and I'll move it over here, and I'll just assign the Lambert to it. So if we go in and render, okay, we don't see, well, we do see it, but just in this kind of faded form. And the reason for that is because you'll see that I'm rendering the edges of this glass. And if you haven't used the toon shader before in Arnold, there's a slightly confounding part of the setup. It's not complex, but it can be confusing. That by default in your render settings under Arnold Renderer, under Filter, the default setting is Gaussian. And that will just render surfaces like this. And there are lots of other filters that you can use that'll be more or less sharp and things like that. But the one that is different is the contour renderer. And that, I guess, is used to calculate the contours of objects. And for the toon shader edges to show up, you have to render with the contour filter turned on. And then to show the toon shader surfaces, you have to render separately with the Gaussian filter turned on. So it's a matter, whenever you do toon shading, you've got to do two renders. One with contour turned on, one with Gaussian turned on in the filter settings. We're not going to get into that here. There's lots of information out there about how to do that. But now we have this Lambert material here. We're still seeing the toon shader there. If I select this and assign a new material and go to AI Toon, then even though we have the Gaussian shader turned on, the Gaussian filter turned on, we can still see the surface because the toon shader does have surface properties, and this is how you get this sort of cell shading look, if that's what you're after. But if we want to make this transparent using the toon shader, let's just turn it around so you can see it in the light. There is a transmission attribute here, and if we turn the weight all the way up to 1, nothing happens. And of course, we always double check by updating our full scene, but no, nothing happens. The only way transparency works in the toon shader is with transmission turned up, but also specular has to be turned up. By default, specular is set to 0, but if we turn that up, now this is acting like a transparent object. It's black here because the rest of the scene is actually black. I've just got it rendering with white in the background right now, but it's refracting the blackness of the rest of space here, and here it's refracting the ground. If I select the ground plane and add a new material, just a Lambert, a regular old Lambert, and then add a checkerboard to the surface, you get a better idea of what's going on. So it's refracting that surface there. So that's how you turn on transmission in the toon shader. And if you don't want it to refract but still be transmissive, you can turn the IOR under transmission to 1, and it essentially becomes invisible now because there's nothing to reflect on the surface, and it is allowing light to pass through, but it's not bending it, so it's essentially invisible. Okay, so you can work with that, but that's just the trick for getting transmission in a toon shader. So now let's just focus on the next part, which is adding the toon outline. So again, we have to use the filter contour, and now we can see both of our contours. This checkerboard is making it a little difficult to see now, so I'll just break that connection and make this brighter. So now you can see that we can see the edges of this. If I go into the toon shader here and alter a few things, so we've got the edge here. Edge color is black. Edge opacity. Width scaling is set to 1, and that's a multiplier of this value over here in the render setting. So if you want to go higher than the thickness of the line, you got to turn it up here in the render setting. So if I set it to 5, then we get thicker lines, and it's multiplied by this, so by 1. So if I set this to 0.5, now we're getting 2.5 width. Okay, so I'll just set it back to the default here and change the width scaling back to 1 here. Anyway, that's all that is. But if we go down a little bit further, we've got edge detection. So it's going to draw an edge where objects intersect. That's ID differences. And if you have different shaders on the same object, it will draw an edge there. But it will also draw edges just based on the shape of the object, the focal discontinuity between the object and its background. So it detects an edge here on the side of the glass, even though it's a continuously cylindrical object, but there's a difference between the edge here and the background, so it draws an edge. It's just the way we draw things too. We look at an object and decide where an edge should go. And you can see that it's not really wrapping the edge around the inside of the glass here. And if we want to do that, we can go to AI Toon and this angle threshold here. If we start to turn that down, let's get in a bit closer, then you can see it's picking up these other edges here. So it's the angle threshold, the angle from this top face going down the side here. So you can play around with that to get different kind of view. Let me change the background color of our render to white, since we're rendering in black. So you can play around with this. If you go too far, you'll start to kind of get polygon shadowing their neighbors here. So you don't want to go too far with this, but you can play around with this to get the look that you like. Okay, so how about making that inside object? Let me just hide this one and we'll go back to the original. So here again, what we're trying to achieve is taking the glass and rotating it, and as it rotates, the top of the liquid inside doesn't rotate as well. It stays level with the ground. And this is pretty simple, and there are probably lots of different ways to do something like this, but I did it with a boolean. So we've got the glass, and inside I've got an object called liquid and an object called cut cube, and they're actually not visible right now because what this object is here is this thing called polysurface1, which I should probably give a better name, like cut liquid. And we're just using a boolean to do this. So let me recreate this. So I'm just going to delete cut liquid, and some weird stuff is going to happen, right? So when I delete that boolean result, then we see our two original objects, but they don't have shaders on them anymore. So they'll turn green here, and then in your renders, it turns the opposite color, I guess, and makes this big pink thing. So we'll just select these two things and assign an existing material, just regular Lambert, and they go back to normal. If we look at it in the side, we can kind of get a better idea. So I just have a cylinder inside here that I made from the inside of a duplicate of the glass. You could also just make a cylinder that fits the inside of the glass. There are some problems that can arise where the faces intersect between the liquid and the glass, and this is a pretty fakey fake sort of approach, and so you just have to make sure they don't exactly intersect. I'll show you in a second what I mean. But what we want to do is to use this cube to cut off the top of this liquid, then have the cube rotate opposite to the rotation of the glass. I'm going to move this cube down a little bit so my surface of the liquid will be a bit lower, but it gives us a little more room to make an angled surface. And you can see that my surface, the liquid surface, just comes up here. It would probably be better if it went right to the top, because you'll see that when this angles, we're going to get a cut edge here that we don't want, but I can live with that. So all we want to do is make a liquid piece of geometry inside, make a big cube that goes all around and will surround the whole thing. And then we make both of those children of the glass, and this is an important point because when we rotate the glass, it's also going to rotate the cube, which is what we want, and the internal liquid, and then we just want to negate that rotation. But this means we can move the glass anywhere we want, and the cube and the original liquid will follow. So now we select both of these. I can never remember the order, but then we'll go to Mesh, Boolean, and one of these differences. So let's try difference AB. Yeah, I did the opposite here, so let me just undo. And we'll select these two. I think I have them selected in a different order now, so let's try AB again. No, that's correct. So let's just delete that poly surface. So now we've got a piece of new geometry down here called poly surface 2. Let's hide cut cube and liquid. I think by default this happens automatically, but because I've been trying this over and over again, I think we've got some strange problems here, but we can just hide them, and then we wind up now with a surface inside here that looks like this. And so let's call this Boolean liquid. So the good thing here is that the original cut cube and liquid exist. They're just invisible. But if I take that cut cube and move it up, you can see the cut surface goes up higher. So you could use this for animating, the liquid draining, or whatever you want. One thing I should note, let me just unhide the cube. Not sure if I mentioned this, but the cube, put the pivot point at the bottom of the cube. So that means when it rotates, it's going to rotate about that point. Just hide this again. And then this new poly surface that was created, boolean liquid, I'm going to assign the same toon shader to it. I've got a bunch of them here now, obviously. And you could assign a different toon shader to it if you want to have slightly different results between the glass and the liquid inside. But you can see now we get a nice edge on the liquid here and an edge on the glass. So we're not quite there. If we rotate the... Okay, I guess I do have it left over. So let's just see how this works. So I'm going to select the glass and the cut cube, and I want to see these in the node editor. So there are different ways to make connections between objects in Maya. You know, there is the connection editor somewhere in here, general editors, connection editor. You can do set-driven keys and so on. But for this, we just want to use the node editor. And if we map out those two things, I've already set this up, so let me just delete this. So we have the cut cube and the glass. And if we just open both of these up, move these things out of the way. Essentially, we want to connect one of our rotations, and I'll use rotate X on the glass, and connect it to rotate X on the cut cube. That's the invisible cube that's being used in the Boolean. But we don't want to connect them directly, which you probably saw me delete a second ago. I've got a multiply and divide node between them. And we want to connect rotate X from the glass into input X for input 1, so input 1X for multiply and divide. And then we want to take the output X and attach that to the cut cube. And the only thing left to do is to go into the multiply and divide node and take a look. So input 1 is yellow, so input 1 X, Y, and Z. We only attach to input 1 X, so that's yellow, it's got an incoming connection. And then input 2, there's nothing, and the operation is multiply, so it's just multiplying this by 1, but if we want to reverse it, we can multiply it by -1. Okay, and that's really all there is to it. So now, with this in mind, if we take our glass and rotate it, you can see the surface is staying level. And it's easier to see if we unhide the cut cube and look at it maybe in this side view here. So if I rotate the glass, you can see that something is happening to the cube. Because it's a child of the glass, when I rotate the glass, the cut cube is also rotated in the same way. But then because I have this multiply and divide node set to -1 in that direction of rotation, it's really just negating that rotation. And so it keeps the cube always level. So let's just hide that cube again. Go back here. Let's just move our ground down a little bit. So when we rotate it, we'll get the surface angling. And the good thing about this is because everything is a child of the glass, if I just grab the glass and move it, it still works because the original liquid and the original cut cube are children of this and they're moving as well. But the Boolean liquid is outside. We don't want to make the Boolean liquid a child of the glass, because if we then move the glass, we'll get a double transform where the glass will rotate or move, and then the liquid and cut cube will move, which will themselves move the resulting Boolean. But if the Boolean is a child of the glass as well, it's being told to do those things twice. It's called a double transform, and we always want to avoid that. But that's why we keep it outside of the glass group here. And really, that's all there is to it. Now, the only thing that you may encounter, let's select the glass, and just zero these things out. Maybe move it up above the floor a little bit. But if I take the original liquid and if I just scale it up, so even though it's hidden right now, I can still do scaling and stuff. If I scale it up, you may see, yeah, here's some slight evidence of it. It's not, you'll see it even more extreme, but these kind of artifacts, this is where there are either polygons intersecting with each other or polygons that are in the exact same position. Then you'll see more of a kind of baffling artifact. But all you have to do to solve it is really just scale it down a little bit so you get rid of that intersection. And then you're just left with something like this that can bend. Now it's going through the ground, so we're getting extra lines there. And we're kind of exceeding the edge of the liquid here. So there are some limitations about what you can do. And like I said, it would probably be better if I made my liquid go right up to the edge from the beginning. Let's just move the ground down to get rid of those edges. And that's all there is to it. So you can use transmission in a toon shader. You can set up this weird Boolean thing. Just remember, when you do toon shader rendering, you always have to do 2 renders for the same object. One for the edges, and that's when in the Arnold render settings type of filter is contour. And then if you want to see the surfaces, you have to change it to something like Gaussian to render those out separately and put them back together in After Effects or your compositor of choice. And that's all there is to it. So I hope this is helpful, and good luck.